All right, so the other side of the coin that we just looked at is this balancing in a basic solution. So balancing redox reactions in a basic solution consists of, well, basically the exact same steps that we had when we were balancing with an acidic solution, but that optional last step we're going to go ahead and do. So what we're going to do is we're going to neutralize any hydrogen ions with hydroxide ions to produce a basic solution. So whenever that's all said and done, you're going to cancel out any excess H2O if it appears on. All right, so the reaction that I've got for us to do is BRO, BRO minus goes to BRO3 minus. Okay, now the first thing that you need to do is figure out, well, this is BRO minus is being oxidized to BRO3, so you know that the electrons are going to be on the product side. Now the question is how many electrons? Well, you can figure out the oxidation state, and the oxidation number of Br is +1. Now the oxidation state of Br in BrO3 minus, well, that would be +5. And I know that because oxygen has a -2 charge. 3 oxygens, 3 times -2. What added to -6 gives you a -1, and that is +5. Okay, so what that means is that this is effectively losing 4 electrons. Okay, now my other reaction, I've got Fe3 plus going to Fe2 plus. Where's the electron? Well, it's over here. Okay, so when it comes to the sequence of events and the steps that I'm following, I've written my half reactions. I'm going to erase some things. I'm going to erase that. I'm going to erase that. So I've written my half reactions. Now, the next thing that I need to do is balance the other elements. I don't have any other elements, so I'm just going to blow past that. Then I'm going to balance my oxygen with H2O. Okay, well here I do need to address that, and what I see is that I've got 1 oxygen in this reaction right here, and I've got 3 oxygen over here, so I've got really 2 H2O here. Okay, so I've balanced my oxygens, step 3 in this, and then I need to balance my hydrogens with H+. And notice how I'm really only working on my oxidation reaction, but that's going to be plus 4H+. Okay, so we're good there. Next up is balance the charge with any electrons. Okay, so if I take into account, make sure that I erase and don't make any mistakes, like because of notes that I've been taking, and divide these up. I'm going to say, okay, well, my oxidation reaction, I have a -1 on the reactant side, and then I've got 4 electrons and 4 protons. Those charges are going to cancel out. And I've got a -1 on the product side that remains. So that is balanced electronically. Then over here, I've got 1 electron plus Fe3 plus yields Fe2 plus. That's balanced. So my charges are balanced. Now the next thing that I need to do is step 6. I balance the number of electrons between half reactions with coefficients. Now this is where I'm going to look at my reduction reaction, and I'm going to say I've got 1 electron that is being added. I need to up the ante on that. I need to increase that to 4. So this is going to be 4E minus plus 4Fe3 plus 4Fe, yields 4Fe2 plus. Okay, as soon as I've done that, then what I can do is I can, okay, so now I've got that common number of 4 electrons. What I'm going to do is combine these 2 species. So this, at this point in time, I'm still doing it as if it's in a acidic environment. I haven't like intentionally written anything like that, but or the only thing that I have that's kind of intentional is that 4H+. But here what I'm going to do is I'm going to set my line for my symbol for reaction. this yield. So I'm going to say BrO minus plus 2H2O plus 4E plus 4Fe3 plus. Now along the way, what I'm going to do is I'm going to pick a yellow, and I'm going to cross some of these out. I've taken care of that, I've taken care of that, taken care of this, I've taken care of this. Now what I can do is write my products. Well, one of my products is 4Fe2 plus. Another one of my products is BrO3 minus. Another is 4E minus, and finally 4H plus. Okay, so I've combined my half reactions. Now, the last thing that I'm going to do is that optional step for reactions in a base, because this is in a basic solution. I'm going to add hydroxide. Okay, so I'm going to add OH minus, but I'm going to add 4 of them. Now, whenever I do that to the product side, I've got to do the same thing to my reactant side. So when you add hydroxide to one side, you got to do it to the other. Now, what I'm going to do with this is I'm going to consolidate as many things as possible, and things that I see on one side and I see on another side, I'm going to cancel out. Now, one thing that I know is that BrO is on only one side of the reaction, and the corresponding molecule to that is BrO3 minus. Then I'm going to go after my irons. So 4Fe3 plus 4Fe2 plus. Okay, I'm going to use my yellow to cross these things out again. So crossed out, crossed out, crossed out, crossed out. Okay, now here's where it gets a little bit complicated, or where I'm going to have to do some work on the fly. Well, I've got 4 electrons on each side, so I'm going to not rewrite this. I'm just going to cancel. I've got 4 hydroxides, I've got 2 H2O, I've got 4 hydrogen ions, 4 hydroxides. So on my product side, I can consolidate those to make 4 H2O. So now on my reactant side, I've got 4 OH, 2 H2O. Well, these 2 H2O will cancel 2 of these out, so I'm left with 2 H2O. So on my product side, I'm going to write plus 2 H2O. On my reactant side, I still have that 4 hydroxide, 4 OH minus. So I still have that basically remains in my final answer. And with that said, this is my final answer. So this is that reaction taking place in a basic environment. Now this is a good question for question number 7, and then there's some like in 9, I think. It varies a little bit. But that's how you do it in a basic environment compared to an acidic environment. You add that hydroxide at the end. I hope this is helpful. Have a good one.